All right, answer the following questions about the glycolate ion, which acts as a base in aqueous solution. And we're given a Lewis diagram. It says, on the Lewis diagram, part A, circle the atom that accepts the proton from when the glycolate ion reacts with water. So in a very similar vein last year, we were asked to circle the hydrogen that's going to be donated. And as we know, this part of the molecule here tends to be the part where the hydrogen gets donated. So I'm going to make the assumption that it's the same part that it's going to accept the hydrogen. That's that COOH group that's present here. We can see here that you have a formal charge here of 0. Here, this formal charge is not accurate, or at least this formal charge is not 0. So to me, this is kind of begging for that hydrogen to be attached here to that oxygen to form, again, that carboxylic acid, that COOH group. It is quite important in the AP chemistry concept. So I'm going to go with that oxygen that's there. Move down here. It says when the glycolate ion reacts with water, it forms glycolic acid in the following expression. And the Kb expression is provided, which is great. So the first thing it asks us to do is at 25 degrees Celsius, 2.5 molar solution produces an OH minus of 1.3 times 10 to the negative fifth. And it asks us to calculate Kb. So, okay, so this is kind of like a modified version of a Rice table to solve for the equilibrium constant here. So Kb equals our glycolate, 2.5, so that's going to be going down here at the bottom. And then we have our OH minus concentration. Remember when you build a Rice table with this? This part here is plus X, especially when we deal with acids and bases. This part here is also plus X. So what that tells me is that the OH minus concentration is the same as the concentration of the glycolic acid. So when we plug this in, we're going to take 1.3 times 10 to the negative fifth. We're going to square it because, again, it's X and X on top here, so it ends up being X squared. And we're just going to go ahead and solve for Kb that way. So 1.3 times 10 to the negative fifth, square that value, and divide it by 2.5. So what I get here for Kb is 6.8 times 10 to the negative 11th. So that's calculated. Part 2 here says, using the answer to part B, calculate the Ka. That's easy enough. If I go and look at my formula sheet, 1.00 times 10 to the negative 14th equals Ka times Kb. So I'm just going to take 1 times 10 to the negative 14th. I'm going to divide that by 6.8 times 10 to the negative 11th. And I end up with a value of 1.5. Ka is 1.5 times 10 to the negative 4th. So again, just utilize your formula sheet and you shouldn't run into any issues with this. So awesome. Okay, let's keep moving on here. Last one, I think. Yes, last question. Oh, so sad. Glycolic acid can be produced from the hydrolysis of methyl glycolate. A proposed mechanism for the reaction is given, and it says a student claims that H3O plus is a catalyst for the reaction. Do you agree or disagree? Well, H3O plus appears in step 1, and we get it back out in step number 2. That is the literal definition of a catalyst in a reaction mechanism. So I would wholeheartedly agree, because H3O plus appears in the first step, and then we get it back out in a subsequent step. So what that tells me is it's used and participates in the chemical reaction. It is not found in the overall balanced chemical equation. We do have an intermediate that's here as well, but this is the literal definition of a catalyst in a reaction mechanism. It starts one step and comes out a second step. So I would wholeheartedly agree with that. So I think that rounds it up. Pretty much everything here. So overall, I think this exam is a little more challenging than what we had last year. For sure. I think there's some easy entry points. I think there are definitely some challenging questions that are here that are going to require a little bit of thought. But overall, it's still pretty tame compared to some exams that I've seen previously. I like it. I like the variety that's in it. I think the variety is a little bit different. I think there is lots of different variety of questions that are here that I really, really enjoyed going through. And I hope you enjoyed going through it as well. So again, those are my thoughts on the 2025 AP Chemistry exam for this year. I hope you enjoyed it. And if you did, feel free to leave a like. Feel free to subscribe. Do what you need to do. All the fun YouTube stuff. All right. We'll see you guys next time. Thank you so much. And we'll see you very soon in the future. Bye, everybody.